Now the fourth question is, let f be a function defined from R to R such that it is twice differentiable function and 1 upon 2y integral x minus y to x plus y ft dt is equal to fx for all x belongs to R and y is greater than 0. We need to show that there exists real numbers a and b such that fx is ax plus b. So we have to show that this fx, it is a linear function for all x belongs to R. Now we know that it is an integral function whose limits are variables. So we'll differentiate this function using Newton-Leibniz formula and we'll differentiate it with respect to x. So if we'll differentiate with respect to x, then we can write this as 1 upon 2y and now upper limit f x plus y into derivative of upper limit, which is 1, minus lower limit f x minus y into derivative of lower limit, which is 1, and it should be equals to f dash x. So we can write this f dash x as f x plus y minus f x minus y upon 2y for all x belongs to R and y is greater than 0. Now what does this condition mean? This condition simply means that we have a function fx say any curve y equals fx and suppose this is some point x and at this value is fx. Now we take up an interval of width y. So this width is y. So this point it is fx plus y, and here also we'll take this y length and it will be x minus y. So this limit here will be fx minus y. So we'll complete this triangle. Then this height is fx plus y minus fx minus y, and this width is 2y. So basically this value is slope of this chord. So we can write this as tan theta or slope of this chord. Now slope of this chord is equal to f dash x, which simply means instantaneous slope for the function is equal to its average slope. Now when for a function instantaneous slope is always equal to its average slope, it clearly means that this fx is a linear function. So fx is a linear function because in this case for all the values of x and for all the intervals of length y, average slope is equal to its instantaneous slope, and which is only possible in the case of a linear function. So we can express this fx as sum ax plus b, where a and b they are real numbers.